Hey there, Buford Middle School students. This is Mrs. Wilborn again, and welcome to Unit 2, Moving Straight Ahead. This is Lesson 3, which is called Simplifying Expressions. And in this lesson, you will learn how to take a long algebraic expression and simplify it. This process is called combining like terms. Sometimes we refer to it as CLT for short, kind of a little nickname. Our essential question for this unit is, how do I simplify expressions? Now remember, you want to have your guided notes with you. You want to be sure that you pause the video whenever you need to copy down vocabulary terms, or if the instructor is just talking a little too quick for you for your handwriting. So make sure that you're using that pause button appropriately. Please also be sure that you're not working ahead and skipping through the video. There are a lot of things that we say on the video that are just as important as the things that we write. Remember, when you're taking notes, that you want to write down everything that the instructor is writing. So if we're writing it on the screen, you should be writing it on your guided notes as well. All right, let's get started. All right, as with the other lessons, we're going to start with some vocabulary terms. And the first term that you need to know is term. And a term is a part of an expression or parts of an expression that are being added together. All right, so let's put a little example, and there's a place in your guided notes for this as well. So if I gave you the expression, remember it's an expression because it doesn't have an equal sign. Okay, equations have equal signs. Expressions do not. So if I give you the expression 3x plus negative 5x plus 7. All right, each part of this expression is a term. So 3x is a term, the negative 5x is a term, and the 7 is a term. So a term is any part of an expression that is separated by an operation. All right, let's look at the second word, and that is like terms. Terms that have the exact same identical variable part. All right, couple things you need to know here is that they have to have the same variable. So write this down. This is very important. And the same exponent. All right, so that's very important. Okay, so the same variable and the exact same exponent. All right, let's look at some examples here. So in our previous example, 3x and 5x are like terms, or the negative 5x, sorry. Okay, just because the signs are different, that doesn't mean anything, all right? But because they have the same variable x and they're both raised to the first power, those would be examples of like terms. Okay, here's another example of like terms, right? If we had x squared plus 3y plus x squared. All right, in this case, the x squareds are like terms because they have exactly the same variable parts. All right, they have both the same variable x and they have the same power of 2, the same exponent of 2. All right, next word, coefficient. And this is the number part of a term that has a variable. All right, well, let's go back to our previous example. So 3x plus negative 5x plus 7. All right, well, our coefficients in that example are going to be 3 and negative 5. All right, it is the number part of the term that has a variable. So these are the terms that have the variable, and the number part is the coefficient. All right, and then finally, constant. All right, constant is a term that has a number but no variable. So if we look back at our example, okay, 3x plus negative 5x plus 7, the only constant term there is 7. All right, because there's no variable attached and it just has a number, it is the constant term. It doesn't change. All right, these terms like negative 5x and 3x, when we substitute in the value for x, those are going to change. All right, so this does not. All right, let's look at some examples here, and we'll do a little bit of identifying. So in this example, we want to identify the coefficients, the constants, constant terms, and the like terms. All right, and here is our expression. X plus 4 minus 2x minus 10. All right, and I suggest the first thing that you do is to go through and actually, with different colors, you can color code with different highlighters, or you can, with different shapes, make different shapes like circles and squares around the terms that are alike. Okay, so we can kind of go through and look at that. That's one tip, and that's something that we will certainly work with you to do. All right, I'll use shapes in this example. All right, so we have x plus 4 minus 2x minus 10. And we're trying to, first of all, identify, let's look for coefficients. All right, so off to the side, go ahead and write coefficients. All right, and if we recall from the examples or from the vocabulary terms, a coefficient is the number that is in front of the variable. Okay, it's the number part of the variable term. So I'm looking for my variable terms. All right, well, here is a variable term, and I'll use a circle to identify it. Here is also a variable term. They both have the same variable, so they are like terms, so I'm going to go ahead and circle that as well. The one thing I do want to point out is notice that I'm circling the subtraction sign in front. All right, and I know we have all told our students that subtraction sign, negative sign, opposite sign, they all do the same thing mathematically. So when you read this question, you may read it x plus 4 minus 2x minus 10. When I'm looking at the signs of each term, the number in front or the sign in front goes with the number behind it. So I'm going to look at this term as negative 2x. If I were to read the question, I would call it a subtraction sign, but they are the same exact thing. So please try and understand that. All right, so my coefficients, I'm still working on my coefficients. If we have a variable without a number in front, we call that the understood one. And I think that I mentioned something similar to that in Lesson 9 of Unit 1, talking about the understood one. So here we see it again. All right, it's just a principle that if you don't see a number in front of the variable, it is an understood one. We have to remember that because if we were identifying coefficients, we would want to identify the 1. All right, the second coefficient is -2. The sign in front goes with the number behind it. Okay? All right, let's move on. Let's look for constants. Okay, so jot that down. All right, constant terms, again, are those parts of number sentences, parts of expressions that do not have a variable tied to it. All right, so I'll use a different shape or a different symbol here. I'll go ahead and underline. All right, so I have a +4 that does not have a variable tied to it, and I also have a -10. Okay, remember the sign in front goes with the number behind it. All right, so my constant terms are going to be +4 and the -10. All right, and then finally the last thing I need to identify are my like terms. So go ahead and jot that down. Okay, and since I've already color coded, or in this case I use different shapes, I already know my like terms. All right, and my like terms here, again, are going to be those terms that have identical variable parts. So my like terms are going to be x and the -2x. All right, we'll get some more practice with this, but really understanding and being able to identify those parts of expressions and equations when we get to that part is going to be very, very important. All right, now that we know the different parts of an expression, now we want to look at simplifying that expression. All right, and when we simplify, we are trying to make something smaller. All right, so in our example, we have 7c plus 9 minus 3c. All right, hopefully you've identified by now that this expression actually has 3 terms in it. All right, it has 7c, a +9, and a -3c. Again, if I were to read this question, I would read it 7c plus 9 minus 3c, but keep in mind the sign in front goes with the number behind it. And I want to simplify, so I want to make something smaller. So I would think after I simplified that I wouldn't have 3 terms anymore. I would have some number of terms that was less than 3. So the first thing I want to do is, again, use my shapes or my color coding to identify like terms. All right, this one I'm going to try, if my pen will cooperate, I'm going to try and do different colors on this one. All right, so let's go, we'll pick blue. All right, and so my first color is blue that I'm going to use, and I'm trying to look for identical terms or like terms. All right, well, I see 7c is a term that has a variable c in it, and the -3c also has a c. They both have the same variable, and they both are raised to the same exponent. So I'm going to go ahead and I'm going to circle those. All right, the 7c and the -3c. Notice that I'm circling the entire thing along with the sign in front. Okay? Now, to simplify these expressions, well, actually, let's look back here, and I'm going to choose another color. Let's go with magenta. And my other term that's left over, I will just, in this case, I'll underline. And I'm going to underline it with magenta, and that term is +9. So now I can easily see what terms are alike because I've used the same colors and the same shapes. All right, let's go back and get my black. And now what I want to do is I want to simplify this expression. So that means that I want to take the terms that are alike and I'm basically going to add the coefficients. So your rules of integers are going to come back. They don't go away. So I have 7c and I have negative 3c. Now when I'm combining, notice that again the term or the part of this lesson is called combining. All right, when I combine, I usually add things together. If I'm making a recipe and it tells me to combine the eggs with the milk, I'm adding the eggs and the milk together. So whenever I'm combining like terms, I'm adding, always. All right, so I'm going to off to the side, way away from my problem, I'm going to combine my like terms. All right, well, I look at the coefficients only. So I have 7 plus my second coefficient is negative 3. All right, and I'm going to add these, and I'm going to go back to my rules for addition. I'm going to ask myself, are the signs the same? My answer in this case would be no. Okay, I have a positive number and a negative number. So I need to find since my signs are different, I find the difference. So 7 minus 3 is 4, and I keep the sign of my larger number. Since 7 was larger and it's positive, my answer is positive. All right, so I'm going to go back to my problem, and when I combine these, I will end up with 4, and I bring the variable, or the c, along for the ride, so it comes along for the ride. So I'm basically adding the coefficients and then making the two terms that are alike into one term. All right, this positive 9 doesn't have a match. I don't have anything else in my expression that has a pink line under it, so it just comes down and becomes part of the next step in solving this question. Now, you are not going to be going on any further than this. I can't go any further on. All right, I can't add 4c plus 9 because they are not like terms. All right, and I don't know what the value of c is, so I can't substitute a value for c is. So this is my final answer. So I've simplified this expression. Simplifying again just means to make it smaller or shorter. All right, I had 1, 2, 3 terms in my first part of my question, and in the end I only had 2 terms, so I did make it smaller. All right, let's look at another one. Sometimes you'll have situations like this, where you'll have 5 times the difference between w and 4 plus w plus 8. So again, it's a nice long expression. All right, well, whenever you see parentheses first, you need to get rid of those. And since I have a number outside, usually that's my hint that I'm going to use the distributive property. When you see parentheses and a number out front, that's when the distributive property comes into play. So before I can start my color coding and combining my like terms, I need to get rid of these parentheses. All right, so I'm going to use the distributive property to get rid of the parentheses. So 5 times w, and you learned this in Unit 1, is 5w, and a positive 5 times a negative 4. Remember, the sign in front goes with the number behind it. Positive 5 times negative 4. A positive times a negative is a negative, and 5 times 4 is 20. All right, so I've gotten rid of my parentheses. I'm just going to bring the next part of the problem down. All right, so I'm just going to bring the w, positive w, and a positive 8 down into the next step of my problem. All right, now I'm going to look for like terms. So I'm going to grab my colors, and let's pick green this time. So, and I'm going to start looking for some like terms. All right, well, I have a term that has a w in it, and I'm going to look at the rest of the terms. Oh, I got a w here. All right, so these are going to be like terms. So in this case, I will use a box, and I'll box these terms in. Okay, again, the sign in front goes with the number behind it. So I want to make sure that I box that positive in as well. All right, double checking, I got all of my terms with W. All right, so let's go and get another color And you're going to keep picking colors until you have all of your terms that have a symbol around it. All right, I have a negative 20 and I have a positive 8. Well, those are both constant terms, so they are alike as well. Neither of them has a variable. So I'm going to, in this case, use circles, and I have a negative 20 and a positive 8. All right. Well, now since every term has a color, I can go ahead and start my adding. Remember, adding because I'm combining like terms. All right, so off to the side here, I'm going to look for the coefficients in my terms that have variables. And I have positive 5, and look right here, this is positive W. Remember that understood 1. All right, if you don't see it, add it in there so you remember. So I'm going to add off to the side. I'll make my number sentence. So 5 plus 1 equals 6. All right, so my W terms, or my terms with W, when I combine them, I'm going to have 6 W. Kind of looks like a B. There we go, that's better. All right, and now let's look at the terms in red. Okay, or in this case, my constant terms. So let me grab my red. And again, off to the side, I have negative 20. I'm going to do all my scratch work off to the side. I'm adding. I'm always adding. And I'm going to add a positive 8. All right, so I'm going to use my rules for integers. Are the signs the same? In this case, my answer is no. So I'm going to find the difference, or subtract, and keep the sign of my larger. Well, 20 minus 8 I know is 12. And since 20 was larger and it was negative, my answer is negative 12. All right, since I have negative 12, I'm going to write negative 12. When I read the question, I would read my answer, I would say 6W minus 12. All right, but when I go through and I look at the signs of the terms, I'm going to say this is a positive term and the 12 is negative. All right, so you have to kind of understand the difference. So the negative sign, I'm just writing negative 12, but then when I read it, it just becomes the operation. Remember, subtraction, opposite signs, and negatives do the same thing. All right, let's look at one more together. I know it's getting long on the video, but this is really important that you understand this. We'll do one more, and then there'll be a couple for you to try on your own. All right, so this we're going to do a little bit of writing and simplifying. So we have to take our word problem and basically turn it into a written expression. So we have a rectangular mat that is twice as long as it is wide. Write and simplify an expression for the perimeter of the mat in terms of W, the width. All right, so here's our drawing. Remember, it's always best to do a drawing when you have word problems. It really helps. All right, and we're going to call our width W, and our length, it tells us, is twice as long as the width. So we say 2 times W, or 2W. All right, so the first thing we need to do is we're talking about perimeter, all right? And hopefully you know that when we talk with perimeter, we're talking about the distance around a shape. All right, the distance around. I'm going to go back and let's get this. So we're talking about the distance around, and our expression that we write has to represent the distance around. Well, hopefully you know that in a rectangle that opposite sides have the same length. So if this side is W, then this side is W. And if this is 2W, well then this side is 2W as well. Okay? So to write an expression for the perimeter, One way, and there's more than one way, we could just basically start at one side, 2w, and continuously add the different sides. So if I start here, 2w plus this side, which is w, plus this side, which is 2w, plus this side, which is w. Okay, so that's one way we could write our expression. Another way we could write our expression is to say 2 times the length, here's the length, because I have 2 of them, 2 times the length, which is 2w, plus 2 times the width, because I have 2 widths, which is just w. Alright, so either way you could write the expression and end up in the same answer. If you're using this way, you're going to have to use the distributive property. Alright, if you write it this way, the number sentence is longer, but you don't have to distribute here. Either way, you'll end up with the same answer. Alright, let me grab a color. And we'll start looking for like terms. I'm going to underline here. And as I look down and I notice all of my terms have a W in it. So they'll all be the same color coding with the same shape. Notice my W here doesn't have a coefficient. Remember, if I don't see a coefficient, I do a 1. If I don't see a coefficient, like in this one again, it's an understood 1, so I need to write that in there. Alright, and now I can just go through and add my coefficients. So I have 2 plus 1 is 3, plus 2 is 5, plus 1 is 6. So in this case, I can simplify my expression all the way down to one term, which is going to be 6w. Alright, if I went this route, I would have to use the distributive property to multiply in 2 times 2w. I multiply the numbers. 2 times 2 is 4, and the w comes along for a ride. Plus, I have another set of parentheses, so another time that I have to multiply and distribute. 2 times w is 2w. Again, I look for like terms. They both have w's and both have the same exponent, so I add the coefficients. 4 plus 2 gives me 6. So final answer, either way, is 6w. Alright, here are a couple questions for you to try on your own. So these are your turn questions. Please make sure that you are identifying the coefficients, the constants, and like terms of the expression, and then also simplify. You will need to have some different colored highlighters or colored pencils and use those to identify the like terms. Make sure that you're using shapes. You can do circles, squares, underlines, as well as the different colors, and I think it really will help you stand out on how to answer these questions. Good luck, and I appreciate your patience, and we will go over these in class tomorrow.